Let's talk electron configuration. The periodic table really gives you a lot of information about how to write the electron configuration of different elements. First of all, we know this block here is our S block. This block here, right, is our P block. This is D, and then when we get into the lanthanide and actinide, that's F. So we should be able to count across to do these electrons. Our periods, 1, 2, 3, 4, and so on. S and P use the period name, period number that they're in, where D uses period -1 and F uses period -2, right? So let's look at, we're going to go to your third sheet. Let's look at chromium. We'll do that one and see if we get to the same answer, all right? Chromium is right here. So we start at the top. In period 1, 1s1, 1s2. So we filled the first S. We come over here to lithium and we have 2s2. Over here, beryllium, we have 2p6. Over here to the period 3, 3s2. Then the 3 p's fill, 3p6. All right, we're down to period 4. Here we go, 4s2. Okay, now we're into the D's, and the D's are the period -1. So that would be 3D, 1, 2, 3, 4. 3D4. If we look back at your sheet, that's what we have, 3D4. Okay? Let's try antimony for fun, okay? I'm going to get rid of this for giggles. Okay, antimony, where are you? I just saw it right there, antimony. Okay, we got, this is a lot of electrons, isn't it? So we have 1s2, 2s2, 2p6, 3s2, 3p6. 4s. Now we're here. 4s2. 3d. 3d10. And then 4p6, right? Over here. 5s2. 4. Whoops, I think I did something a p when it should be a d. This should be a d. Okay, 4d10. Now I'm into my 5p. 1, 2, 3. 5p3. Now that's all great, but that's really long. So that's why they come and they use this noble gas configuration. So what we do is we go back to the most recent noble gas as we work backwards, and ours would be krypton, right? So we take the krypton, and that means whatever the krypton electron configuration is, now we add a few more things. We come here and we add the 5s2, the 4d10, and the 5p3. It makes it neater, easier to look at, okay? So that's why they have that electron configuration abbreviation using the noble gases. So let me come back here, kind of clean this up a little, and we're going to talk about spins, all right? We look at, here, I don't remember the name of the rule, but 2 electrons, if they're occupying the same suborbital, they have to have different spins, don't they? I don't know whose name that is. Then there's another rule that says if you have, within an orbital, if you look at the suborbitals, so here's a p, right? And I have 3 suborbitals. The electrons will fill 1 in each suborbital first before it comes back to put the other electron in that suborbital. So if I'm in a p and I have 4 electrons, it will fill 1, 2, 3 before it comes back to fill this. You will not see this. This does not fill. You have to fill 1 electron in each suborbital before you move on. Okay? Now, this sheet, it looked like you had everything right. Identify what is wrong with this picture. We just talked about it, didn't we? Write the orbital diagrams for these. So let's try, we're going to try scandium. Scandium. Let's go on the periodic table and find it. Whoops, that's not what I meant to do. Oh, okay, let's go on the periodic table and find it. Scandium. It's in the D's, isn't it? Isn't that funny? There it is. Okay, so it says, let's talk about how its electrons would be. Let's go back to what you had. So scandium is in the, these are the SP, it's in the D. The D holds 10 electrons. It has 5 suborbitals. As far as I'm concerned, scandium has exactly 1 electron in that 3D. So scandium should look like that. That would be my take on it. Let's go back here. Let's look at selenium. To find selenium, it is right here. Now, ends up in the 4 P's, right? In 4 P's, we have 3 suborbitals, so it should be 1, 2, 3, because he's 1, 2, 3, 4 electrons into the 4 P's. Okay? That's what I'm thinking that's asking on this sheet. Oops, sorry. Use arrows, write complete or orbital diagrams. Yeah, I think, Daniel, that those may not be right. These all look right. Let's see, how many unpaired electrons does cobalt have? Let's go back to cobalt, right here. So cobalt is in the 3D. And she has 1, 2, 3, 4, 5, 6, 7 electrons in that 3D. There are 5 suborbitals. 1, 2, 3, 4, 5, 6, 7. So indeed, it has 3 unpaired electrons, which you have perfectly right there. Let's look at this. What column of the periodic table contains elements whose electron configurations end with 4D? Let's come back here. So 4D, 1, 2, 3, 4D is right here. Okay, that's the column whose electron configuration ends with 4D. And then it says, I think this is just the same question. What row of the periodic table contains elements with 4D electrons? We said that the D's are always the period -1, didn't we? So this is 1, 2, 3, 4, 5. These are the 4 D's, so it is in row 5. So you had that right. You're good. Check. Good. What row of the periodic table contains elements with 3 p electrons? Well, p's match the row number, so that's 3. In each row of the D block, there are only 10 elements. Why is this? Because there are 5 suborbitals in D, and we can only hold 10 electrons. Same thing here. In each row of the P block, there are only 6 elements. Well, P orbitals, which have 3 suborbitals, can only hold 6 electrons. That's what we're looking for there. So I'm hoping this helps you on these electron configurations. Like I said, I'm not sure about this here. You may need to double check it, but I think you had the rest of this correct. So take a look at this before you and I talk, and maybe that'll minimize, or it'll bring back up other questions that you need to ask. Okay? Thanks.